The 14th of October, 1943, altitude 25,000 feet, temperature -40. 60 miles from Schweinfurt, the sky is a killing field. A formation of B-17 seconds staggers under flak bursts that bloom like black flowers. German fighters tear through the bomber stream, Bf-109 seconds and W-190 seconds, slicing from 12 o'clock high to 6 o'clock low. Inside one fortress, Sergeant Bill Haskins grips the handles of his 50 cal Browning. He fires a 2-second burst, 36 rounds. Half of them miss, the rest drift harmlessly behind a diving Messerschmitt. His barrels glow cherry red, his gun jams. By the time he clears it, the fighter has already set another bomber ablaze. In less than 20 minutes, 60 bombers vanish from the sky. Back in England, officers tally the numbers. It isn't bravery that failed them, it's physics. The 50 cal Browning M2, America's heavy machine gun, was supposed to be unstoppable. John Browning's 1,918 masterpiece could fire 850 rounds a minute, spitting half-inch bullets with enough energy to cut a plane in half. But in the air war over Europe, enough wasn't enough. Fighters attacked head-on, closing at 600 miles per hour. In the blink of an eye, a German pilot flashed across a gunner's sights. To score a hit, a man had maybe 2 seconds to fire, and his weapon was already choking on heat and friction. At Springfield Armory, engineers were desperate. They lightened bolts, tested new springs, polished feed ramps, but every attempt to raise the firing rate ended the same way: cracked bolts, scorched chambers, and catastrophic failures. They told the generals, 850 rounds per minute is the limit. Beyond that, the gun destroys itself. But the generals had a different calculation. Every 10 seconds a fortress fell, and with it, 10 men. By late 1943, the 8th Air Force was bleeding. Crews were calling daylight raids suicide flights. General Hap Arnold summoned his ordnance teams. We need more firepower in the same space. Figure it out. Meetings stretched into the night. Diagrams littered tables. Engineers argued about metallurgy, about spring rates, about human limits. Someone even proposed switching to 20mm cannons, an idea quickly buried under logistics. Still, no solution came. The Browning M2 had reached the ceiling of human engineering, or so they thought. Then, out of nowhere, a name appeared on an obscure manufacturing report. Frigidaire Division of General Motors, Dayton, Ohio. They weren't weapons designers, they made refrigerators. Yet they'd been contracted to mass-produce Brownings for the war effort, and inside that factory, 2 civilian engineers were quietly studying a problem no one else dared to touch. Thomas Olmsted and Ernest Linden were mechanical engineers, not soldiers. Their world was compressors, pressure valves, and thermal cycles. But as they inspected hundreds of M2s fresh off the line, they noticed something odd. Most failures happened in bursts, literally. The gun wasn't breaking because it fired too fast. It broke because it fired unevenly. The thermal stress built up like a heartbeat out of rhythm. To them, the Browning wasn't a weapon. It was a badly tuned engine. They ran the math. In a refrigerator compressor, fluid dynamics smoothed oscillations. In the M2, recoil and return springs clashed in chaotic rhythm. What if, just like in a cooling system, they synchronized the cycle instead of resisting it? It was madness. But madness had built the Manhattan Project. Why not a machine gun? One night in March 1944, after the last shift clocked out, the 2 men stayed behind. On a dimly lit bench sat a stripped-down Browning M2, their patient. They lightened the bolt by a few ounces, filed down the accelerator cam, modified the return spring geometry, and most critically, they shortened the bolt travel by 3/16 of an inch, just enough to reduce cycle lag without upsetting the feed timing. They mounted the gun, locked in. a test belt, and took cover behind a steel plate. Olmsted called out, "Ready!" Lyndon pulled the trigger. The first burst cracked like thunder. The gun didn't stutter, it screamed. Empty brass poured out in a golden waterfall. When the belt ran dry, the test camera showed a firing rate of just over 1,200 rounds per minute. The barrel hadn't split. The bolt hadn't fractured. They looked at each other, disbelieving then at the smoking weapon. The impossible had happened. The next morning, they brought their data to the Army Liaison Office on site. Instead of applause, they got interrogation. "You modified government property without authorization. Your data's unverified. Your methods violate Springfield's testing protocol. Their prototype was seized. The report is buried." Weeks later, a formal rejection arrived. "Increased cyclic rate, not sustainable for field use. Design is non-viable. But factories have gossip, and gossip has wings." A machinist who'd witnessed the test mentioned it to a regional production manager who happened to brief General Motors' board. Within days, the GM president himself requested a demonstration. And if the GM called Washington, Washington listened. 2 weeks later, the skies over Dayton thundered again. This time, the audience was a group of generals, Springfield engineers, and the skeptical liaison officer who'd tried to bury the design. They fired both guns side by side. The standard M2 rattled like a drumbeat, the prototype a continuous roar. The slow-motion camera revealed the truth. 1,200 rounds per minute, stable, controlled, perfect. No one spoke for several seconds. Then one general turned and said quietly, "Build me 1,000 of these." The weapon became the ANM-3 Browning. Its debut came in the closing months of 1944, mounted on America's fastest aircraft, the P-51 Mustang, the P-47 Thunderbolt, and later, the P-38 Lightning. Pilots immediately noticed the difference. Where the old Brownings pulsed, the new ones sang a solid, furious tone that ripped through aluminum and armor alike. A Mustang pilot wrote in his logbook, "It's like firing a beam. The enemy plane just disintegrates." The Luftwaffe called it the Silver Roar. Japanese pilots called it the Wall of Bullets. With 50% more rounds in the same firing window, the odds shifted overnight. Head-on passes became death sentences for enemy fighters. Even bombers, once easy prey, now punched back with terrifying intensity. And above all, the losses stopped climbing. For the first time in months, bomber crews started coming home. When the war ended in 1945, only a few thousand M3S had seen combat, but their influence spread like wildfire. The Air Force standardized the design. Navy and Marine aircraft carried them in Korea. By Vietnam, the M3's descendants, faster, lighter, electronically triggered armed gunships and helicopters. What started as a refrigerator company's experiment became the backbone of modern aerial firepower. Yet, Olmsted and Lyndon never sought recognition. They returned to civilian life, working on post-war appliances and industrial cooling systems. In a rare interview decades later, Lyndon laughed when asked how 2 civilians had out-engineered the U.S. Army. "We didn't know enough to know it was impossible," he said. "We just fixed what was broken. Sometimes genius doesn't roar. It hums quietly like a compressor." Archival footage fades in. Jets streak across the horizon. Door gunners fire M3S into the jungle canopy. The sound is the same, that tearing roar born in a Dayton workshop. The narrator's voice lowers. In war, not every hero wears a uniform. Some wear coveralls and carry slide rules. Over a slow zoom of the gun firing in perfect rhythm. The M3 Browning, born from refrigerators, forged in desperation, perfected by civilians, fade to black. The sound lingers, that endless, thunderous stream of fire before it cuts abruptly to silence.